Okay, so for the multiple choice parts, starting with question 1, selected values of a function g are shown in the table above. What is the average rate of change of g over the interval from -2 to 2? This is so easy. So we're going to do 5 minus -3 over 2 minus -2. So it looks like it's kind of left in this sort of notation. So I think it's got to be B. Cool. Let's go to 2. So let f be the function defined by f of x is equal to 2 sine of x plus cosine of x. The average rate of change over the interval from 0 to b is 0.05, where b is greater than 0. Which of the following is an equation that could be used to find the value of b? Good question. Okay. Which of the following is an equation that could be used to find the value of b? F b. Okay, the average rate of change of f over the interval from 0 to b. So if you were to write this, the average rate of change, you would say f of b minus f of 0 over b minus 0. So f is defined as a function. The average rate of change of f over the interval is 0.05. So if this is the average rate of change, we're saying that this is equal to 0.05. So that's got to be C right there. Okay. For 3, let f be the function defined by f of x is equal to secant of x plus cosecant of x. Which of the following expressions is the average rate of change of f over the interval from pi 4ths to 3 pi 8ths? So that would be f of 3 pi over 8 minus f of pi over 4 over 3 pi over 8 minus pi over 4. So it's got to be C. Man, what the heck? We're not even doing any math right here. Like, we're just writing out the function notation. We're letting all this beautiful trig go to waste. That's unfortunate. For number 4, let f be the differentiable function with f of 1 is equal to 3. Okay. F of 1 is equal to 3. So notice that this graph is the graph of the derivative. This is not the graph of f. It's the graph of its derivative. Okay. So you can see here, if you try to look at f of 1, and you saw this right here, and you're like, well, wait, f of 1 is 2. No, f prime of 1 is 2. F prime of 1 is 2. The graph of f prime, the derivative of f, is shown above. Which of the following statements is true about the line tangent to the graph of f at x equals 1? So what we know from the relationship between the graph of f and the graph of f prime is that the graph of f prime will tell you the slope of the graph of f. So the slope of the graph of f at x equals 0 is 1, while the slope of the graph of f at x equals -1 is 2. And then the graph of f at x equals -0.5 is 1.5, so on and so forth. And so what do we know about the line of the line tangent to the graph at x equals 1? Well, I can tell you that at x equals 1, the slope of the graph of f is 2. And the slope of the tangent line has to also be 2. So if you have a graph and there's a tangent line at x equals 1, the tangent line will have the same, the slope of the tangent line will have the same value as the slope of the graph. And so the tangent line has a slope of 2. Yes, at x equals 1, it has a slope of 2, not a slope of 0. So it can't be C, can't be D, and passes through the point 1, 2. No passes through the point 1, 3. That's stated here. So our graph, the graph of f, which we can't see, passes through the point 1, 3, and it's going to have a slope of 2. The tangent line is going to have a slope of 2, and the graph is going to have a slope of 2, but yeah. For 5, an equation for the line tangent to the graph of the differentiable function f at x equals 3 is y is equal to 4x plus 6. Which of the following statements must be true? Oh boy, one of these ones. Okay, so an equation of the line tangent to the graph of the different... This is not hard, but a lot of students do have a hard time with this problem. But it's really not too bad. Okay, so an equation for the line... It's probably... An equation for the line tangent to the graph of the differential function f at x equals 3 is given here. Okay, so let's see if I can give some sort of illustration that can kind of help. So we have 4x plus 6. So let's call this 6. We know that our line, this equation of this line is right here. It has a slope of 4, so a pretty narrow slope. So I'll call this right here 4x plus 6. So this an equation for the line tangent to the graph at x equals 3 is 4x. So this is the tangent line. And it's tangent to the graph at x equals 3. So I'm going to call this right here, I'm going to call that x equals 3. So I don't really know what f looks like. But what I do know is that at x equals 3, so maybe like right here, the graph of f has to intersect right there, but it can only just intersect by touching it. So the graph of f might look something like that or something like that. I don't know. Or it might look something like this right here. But what I do know is that the graph of f at this point is going to have a slope of 4, because that is the slope of this tangent line, and that's the only way for the function to intersect with the tangent line is if the slope of the tangent line has the same slope of the graph at that point right there. But again, I don't really know what f looks like. So let's read the rest of this. Which of the following statements must be true? Okay, f of 0 is 6. So right here, it's saying that the function has to be 6. Now, this line right here is that of the tangent line, not of the function. So I don't think that this is it doesn't have to be true. So the graph of f could do something like this right here, where maybe like, I don't know, maybe it like crosses right here, and I don't know, does something weird like that, and then at this point right here, it's going to have the same slope. So it could pass through here, but we don't know, and it doesn't have to. F of 3 has to be equal to 18. So at x equals 3, it has to be equal to 18. Well, that depends. Let's look at this right here. If I plug in 3 right here, I know that this isn't the function, but this is the tangent line. So so if I plug in 3, I get 12 plus 6, which is equal to 18. So this must be true, because at the point of tangency, this is the point of tangency, the graph of f and the tangent line have to have the same point. So because it's a tangent line here at x equals 3, that means they also share the same point, because our line has to intersect right here. Has to. So if the tangent line has the property that its y value is 18 at x equals 3, then so does the function of f. So that has to be true. And f prime of 3 is equal to 4. That is also true, because that is the slope of the tangent line. The slope of the tangent line, well, this is always 4. And then our graph of f, again, it will intersect right there. Something like that right there. and it's going to have a slope of 4 because it is tangent at that point. So it's going to be 2 and 3 only. And finally, for question number 6, shown above is the graph of the differential function f along the line tangent to the graph of f at x equals 3. So we have the graph of f, we have tangent line, and kind of rambling on a little bit more as from up here. So this is a picture where we actually do have the graph of f and tangent. So what do the tangent line and the graph of f have in common? They always have a point. So 3, 4, they share that same point. Okay, and the slopes have to be the same. So the slope of this tangent line has to be the slope of the curve at that point. So what is the value of f prime of 3? So here is the graph of f. F prime of 3 means the slope at this point at 3. Well, since we're also tangent at this point, I can just take the slope of the tangent line, and the slope of the tangent line will tell me the slope at that point right there. And so the slope of this tangent line is, well, first of all, it's decreasing, so it has to be negative, so it can't be C or D. And then it's 1/2, so negative 1/2. Okay, and there you go. That's everything for this homework.